It's our video for Unit 6, Day 2. So what we're going to focus on today is angles and parallel lines. So specifically, we're going to focus on when we have parallel lines and a line that goes through them, which angles are going to be the same, and different ways of classifying these angles, different vocabulary terms describing these angles. So what are parallel lines? First of all, basically they're lines that don't intersect. So lines in the same plane that don't intersect are called parallel lines. Now if we have a third line that crosses two other lines in the same plane, that's called a transversal. So it's a third line that intersects our first two lines. Alright, so if we look at our picture diagram here, a couple questions at the bottom. Which lines are parallel? Line M and N are parallel. We can see that they're both going straight. They're not going to intersect in either direction. So the way we write that with our notations, we say line M, we use this little symbol for parallel to line N. So how we'd mark that on a picture, on a diagram, is we use little arrows like this to show that these are parallel. So which line is the transversal? That would be line T. Alright, see that line T comes down and intersects these two lines, which makes it a transversal. So now that we have the kind of basic setup vocabulary behind the types of diagrams we're going to be working with, the pictures you're going to see, the kinds of geometry tools we're going to do, we're going to talk about these specific types of angles that we see formed at intersections. So angles whose sides form two pairs of opposite rays are called vertical angles. Another way of saying this, more easy way of thinking this, these are angles that are across from each other at an intersection of two lines. So a special property about vertical angles, the reason they have their own special name, is vertical angles are always congruent. So anytime you have two lines intersecting, and remember that congruent means equal in measure. Anytime you have two lines intersecting, the angles on the opposite sides of those intersections are going to be the same. So name two pairs of vertical angles in the picture. Well, we have angle 1 and angle 3 would be vertical angles, right there across from each other at the intersection. The other pair would be 2 and 4. Right, they're across from each other at the intersection as well. So now we're going to go through what I like to call a diagram questionnaire. We have a little setup, a picture that illustrates the situation going on. It gives us some information and asks for the other measurements. So here it tells us angle 1, this angle right here, is 40 degrees. What are the measures of the other three angles? Well, we know that angle 3 would have to be 40 degrees also, since they're vertical angles. And if we look at angle 1 and angle 2, they form a straight line, which means that they should add up together to be 180, which would make angle 2 140 degrees. And if angle 2 is 140 degrees, angle 4 would have to be 140 degrees also, since they're vertical angles and they have to be the same. So one thing we notice about this picture, every two adjacent angles, right, adjacent means next to, Every two adjacent angles in the picture form a straight line or a straight angle, which means that they add up to 180 degrees. So that's an idea we're going to be using a lot in these geometry units, is seeing straight lines. We know that measurement has to be 180 degrees as an angle. Alright, now we're going to have a lot of vocabulary that comes from this picture here, the two parallel lines cut by the transversal. So they have angles on opposite sides of a transversal. And inside of the two lines that intersect, those are called alternate interior angles. So alternates are on opposite sides of transversal. Interior because they're inside the two lines the transversal intersects. If those two lines are parallel, alternate interior angles are going to be congruent. They're going to be the same measure. So if we look at this picture here, this diagram, there's two different pairs of alternate interior angles. First, look at angle 1 and angle 4. They're both inside of those two lines, transversal intersects. They're on the opposite side of that transversal T. Makes them alternate interior angles. We also have angle 2 and angle 3. Same thing, they're inside of lines M and N. They're on opposite sides of angle T, so they're alternate interior angles. Now, next term we're going to talk about angles are on opposite sides of transversal, but outside of the two lines that intersect. Those are called alternate exterior angles, since they're outside. And again, if the two lines cut by a transversal are parallel, alternate exterior angles are going to be congruent. Again, if you look at our diagram here, find two pairs of alternate exterior angles. Well, the exterior angles would be 5, 6, 7, and 8. They're outside of the lines M and N. 5 and 8 are on opposite sides of transversal, so that'd be one pair. And 6 and 7 would be the other pair. They're exterior and opposite sides of the transversal. So next I have angles called corresponding angles. These are angles that are not adjacent to each other, but they're on the same side of the transversal. So they're not adjacent, but they're on the same side of the transversal. These are called corresponding angles. And again, if the two lines cut by a transversal are parallel, the corresponding angles are going to be congruent, just like with alternate interior and alternate exterior angles. Look back at our diagram. So we're looking for two angles on the same side of the transversal that are not next to each other. So let's say, as an example, that I start with angle 6. The other angles on the same side would be 4, 2, and 8. So 2 would be the corresponding angle. So 6 and 2 would be an example of corresponding angles. Another one I can look at is 8 and 4. They're on the same side of the transversal, not next to each other. 8 and 4 would be another one. Looking at the other side of the transversal, I would say angles like 5 and 1, angles like 3 and 7. Those would be another examples of corresponding angles. So now we have all these different angle measures. We understand that they'll be congruent when we have two parallel lines cut by transversal. What we're going to do now is one of these parallel line diagram problems. So here we have these two lines are going to be parallel, line M and N. And we're given the measure of one angle. This angle right here is 20 degrees. Now we have to find all of these angle measures. So we'll show you one example of how this works, and you can do some practice on your own. So the first thing I can tell from that 20-degree angle is that angle 6 has to be 20 degrees also. And the reason I know that angle 6 has to be 20 degrees is because it's a vertical angle with a 20-degree angle. So next thing I see is that on the opposite side of the transversal, but inside of the parallel lines is angle 3. So 3 is an alternate interior angle. Since these lines are parallel, 3 has to be 20 degrees also. It's an alternate interior angle with a 20-degree angle. Right, there's a lot of different ways you can get from one angle to the next. We could also say that angle 3 is corresponding angle to angle 6. So both of those would be okay. Once I have angle 3 is 20 degrees, I also know angle 2 is 20 degrees. Because angle 2 and angle 3 are vertical angles. So now I start looking for my other angles, and this is where I bring in the idea of linear pairs or supplementary angles. Look at the top where I just wrote that 20 degrees for the 2. I see the angle 1 and angle 2 together form the straight line M. So together their measure has to be 180 degrees. So if angle 2 is 20 degrees, angle 1 has to be 160. So that together they form that straight angle. So we say it forms a linear pair with angle 2. And now from here we can use the same kind of logic we were using before. Angle 4 is going to be vertical angles with angle 1. So it's going to have the same measure, 160 degrees. Angle 5 would be corresponding to angle 1, or alternate interior to angle 4, or we could also say linear pair with 20-degree angle, or linear pair with angle 6. And then angle 7, we could use any of them. Again, we know it's going to be 160 degrees. It forms a linear pair with a 20-degree angle with with angle 6. It's corresponding to angle 4, vertical to angle 5. You could even use alternate exterior. Just use all of our vocabulary terms. Alternate exterior to angle 1. So on these, and with a lot of things in geometry, it's not so important just getting the right answer, but being able to explain where it came from or what chain of logic you used to get there. On the next sheet for the practice, you'll see that on the 4 problems on that page, you don't just have to find the angle measures, you also have to say how you know angle measures are what they are. So it's not just the number itself, it's also the reason. So your practice page that you're going to be working on after these notes, you have the answer and you have the reason. So both pieces are important as we work through geometry. So do these practice problems. I want you, especially with the practice sheet, to focus on the reasoning behind the answers you're getting. Use some of these vocabulary terms we have on this page, the vertical angles, linear pairs from yesterday, alternate interior, alternate exterior, corresponding angles. Try and see if you can use all of those terms when you answer these. If you want to look up any other resources or any other videos to help you with this, you can look up parallel lines cut by a transversal.